Hello again, people. We're going to take a look at this radio here today, and this is a, actually I can't tell you what it is because I have no idea what the model number for this thing actually is or anything. And this is a radio that definitely looks much older on the outside than it actually is on the inside. And I guess it's basically meant to be like a modern replacement for like an old, like vintage style radio for like a classic vehicle. And the problem with it is that apparently it doesn't produce or it's not outputting any audio. Now, I don't know for sure. I have not tested this myself. I guess this is made by a custom auto sound, although on the side here it does say modified and engineered in the USA, made in China. So it looks like it's just some sort of a stock radio that's just been like minorly modified in order to look vintage like this. But let's see. First of all, gonna have to find a way to power this, and it did have this connector in the back, but unfortunately all the cables were cut like super short, so I had to extend the power or like the battery, the ground, and the accessory leads because they were too small otherwise. I didn't bother extending any of the speaker outputs because I can just poke into those. I'm going to be using these needle like banana plug adapters, so I can just like put a wire in through there and then use this to puncture it to make contact with it. So that'll make it kind of easy, and I'll prevent like shorting out anything here on the outputs. They used blue for one of the channels. That shouldn't matter too much. It's just kind of odd that they didn't go with like purple, because usually it's like gray, white, purple, and green. So that's not a remote lead or anything like that. At least it shouldn't be. That wouldn't make any sense. The only other wire that's not going to be used is this orange one, but that should only be for the illumination, and that's not one of the things that is apparently an issue with this thing. So first of all, though, I do want to verify that these wires are what they are, colored as. So let's see. Let's open up the bottom. And there are 3 screws that hold each side of the case on, like this top part and this bottom part. So I'll have to remove those 3 Phillips screws right there so I can get a look at the bottom of the board. Or the bottom of the main board in there. All right, got all the screws removed. Let's go ahead and open up this bottom cover. It's a little tight over here on the right. There we go. And it's covered with cardboard. This is kind of like fish paper. So move that and come on, focus. There we go. So, well, that might be problematic. I already see some corrosion in there. So that could be part of the reason why there's no audio output. That looks like it goes into the amplifier, I see for sure. But anyways, I want to see what's what here. So we have this thing plugs in like this. So this bottom here should be ground, and yeah, that first pin right there is definitely ground. The second one should be battery. That goes to a small trace right there that does not look like battery. Shoot, it looks like this orange one might actually be battery, because that one would be this top connection here, and you see that trace there is pretty thick. And I'm guessing that's probably going to be a diode there, so like a reverse current diode or a reverse polarity protection diode. This does not appear to be wired in a standard manner, or at least the colors are not standard. All these do appear to be speaker outputs, though, because you can see how they all kind of go off over here into the audio amplifier section. Okay, well, I guess we should look at the top side of the board then. All right. So there we are. We got this material here falling apart. It's, ooh, that's crispy. So that'll have to come off. And there's a bunch of debris in there. Just going to try to dump it out. Yeah. Okay. Well, things on this side over here don't look so hot. And the solder job on that connector there looks not very good. So I'll probably try to touch that up. Oh, and yeah, look at all that corrosion right there. That those vias look like they're completely eaten through. So that's going to require some touch up. I'm wondering if this brown stuff here is that adhesive that turns conductive when it gets old like that. And yeah, there's a diode right there. So that's definitely a reverse polarity protection diode. This here might be like a voltage regulator. I'm going to guess that it's probably like a 5-volt voltage regulator. So I think what I'm going to start by doing here is just removing that bottom board and disconnecting all this stuff. I'll probably just clean it up first so we can get an idea of what we're looking at. Here's the board removed from the case, and a lot of this adhesive is scraping off fairly easily. But I want to get like everything around these two big capacitors cleaned up. And I'm also going to remove like that capacitor right there at least. I thought it was a voltage regulator, but it looks like it's a transistor. But it could be being used as a voltage regulator. Not sure yet. But yeah, so I'll remove all of that stuff right there so I can clean off all the adhesive. And I'm also going to remove this connector. And then we'll see what sort of damage we're dealing with. So first of all, I'm just going to put some flux here around these capacitor pins and around all of the connector, rear connector pins. And let's put some around that too. Capacitor. Actually, I'll probably do both of these capacitors. They're both the same value, so it doesn't matter where they go really. We'll also check the capacitors, make sure that they're okay. Okay, and that's with everything removed. We'll have better access here to be able to get in here. And I'm going to try to scrape off as much of this adhesive as I can, using this like plastic blade here so I don't like gouge into the copper or anything like that. You can see how it's basically pulling off like everything. There's a little capacitor right there. I'm going to try to be careful with that. But yeah, we'll take a closer look at it here in a second under the microscope, and we'll see what these surfaces look like once I've been able to get all of this stuff off. So give me a second, we'll be back. The plastic blade wasn't quite cutting it. You see what I did there? So I ended up having to use this metal, like, flat blade here that I can use to sort of like scrape up all this stuff, because it's, in some places it's really stuck on pretty hard. So I'm trying to be careful not to gouge like I said, the copper too much, but it is helping. And I ended up removing these two small capacitors there because there was still adhesive there and I didn't realize those were in the way. So it's coming off. I did lose a via right there, so I'm going to have to fix that, but that's not a big deal. Now that the board has had all the adhesive removed and I've cleaned it up somewhat, let's go ahead and assess the damage. So what I thought was an IC right here actually turns out to be a MOSFET, and that's this little part right here. So that's an FDS 4435, and we can see how all the pins on this side are all connected together. So that side there's the drain. These three are all connected together. That's the source, and this lone pin right here, that's the gate. So the board here has provisions for either this SO8 package or for like a TO220 type device. And we can see right here that this gate goes off to this trace, and it goes to that via. And that via there's not looking so hot, so that could be an issue there. So we're going to have to jump this one over from there to the other side, just to be sure that it's not going to become a problem later on. We also have another via right here that looks like it's got some crusty stuff in it. So, I mean, that still looks like it's like leftover adhesive. I'm going to have to get a pick or something and try to like scrape it out. We may need to jump this one as well. I'm not entirely sure yet. And the other device that was here, that's a transistor. That's this 2SD 2058. And that's just a standard or just a regular transistor. So we can do a diode check on this one and see if it's good. I don't think it's bad, but we'll check it anyway. And we see right here that we're missing some material there, but fortunately this is not attached from here to there. There is another trace on the bottom side of this, so it looks like this is just like a ground plane that just was basically kind of goes around it, but doesn't actually make contact there. So this over here should be okay. These resistors all look fine. Got a little piece of crap still left right there. Okay, so on this side, we got a via right there that I think did have some of that adhesive on top of it. It's, and you can see it's scraping off there. So I'm going to have to check that. It looks like there is material there, so maybe that's fine. These traces were the ugly looking ones. This one here looks like it's definitely missing material. So from here to here, do we have contact? No, that's broken. Make sure that this is working. Yeah, that's working. So, yep, that trace is broken. Let's check this one here. that trace is okay, but it doesn't look great, so we'll probably touch that up a bit. That right there is also missing material. We could check it like this. See, we've got no contact there. From here to there, we do have continuity, but all this stuff here looks like it's been like etched, so I'll probably put something here to help like power the delivery there so that it's not at risk of like this corroding away anymore. Although I cleaned it up as best as I could, so it shouldn't corrode anymore, but we'll help it out a little bit. This is all just like ground plane right there. We've got, actually I guess that's solder in there. This capacitor, that little tiny one right there, it looks like it's mostly for bypass. And I mean, I'm not going to be able to check it like that, but the top side here looks like it's gotten corroded away. And I should probably zoom in a little bit on that so we can get a better look at it. There's a better view so we can see how we're missing material over on this side. So I could probably replace that with something that I'll see what I've got on hand. But like I said, even if this was missing, it probably wouldn't affect things like too much. We got some traces right there. You can see how the solder mask has basically sort of been like detached from underneath. So the copper underneath is fine. So it doesn't look like it's really corroded too much right there. We see how this is all just coming off. The other capacitor right here, this, I'm not sure if it's broken right there. Let's see. Put that there. Touch this here. Looks like it's still fine, so that one should be okay. We'll just make sure to touch all this up with some solder mask, UV solder mask stuff so that it covers it up. We've got more material there that was etched, but it's still there, so that should be fine. See right there, this is got a nice little coating of stuff right there, so that's still coming off. This resistor doesn't look too hot, but it doesn't look like it's been eaten away. It looks like it still has its resistive material. Let's see if we can check what that is. About 47.5K. That's probably, oh, that might be okay, because we see right here we've got 473, so that would be 47K. So this might be fine. That reads a little high, but it seems to be okay. I don't know if maybe that needs to be soldered on there a little bit better. What about this one? Yeah, it's close to that 47 there, so I think that these are fine. So yeah, I think this one should be okay if it is a 47. Yeah, so we'll leave that alone. And nothing else in this area really looks bad. We've got some more damage right there. That via there looks okay going to that resistor. The diode here, this one looks fine. It's missing its little black band up on the top right there. The other one, however, this one looks like it got etched. So it's the glass is very kind of like yeah, etched looking right there, unless it's just the coating of the adhesive or something. Yeah, I'm not sure, but it's really gritty feeling. It doesn't feel like smooth like this one does. But it looks to be intact, so I don't think I'm going to worry too much about that one, even though there's still a little bit of adhesive around these areas. Yeah, next step is I'm going to go through and make sure that any vias that may be compromised, we have a jumper going from one side to the other. And then we'll touch up all these open areas with solder mask. Fix up that trace right there. And I think that should be good. We have this via right there actually looks bad. I hadn't noticed that one. So that comes up from the opposite side. That's going to be one of the speaker terminals. So we will be touching that up. We'll get a jumper from here to the other side. The rest of these are all from the bottom. That's the 12 volt coming from the battery. And that was that orange wire. So it's not the red one or the yellow one that's being used as the battery. It's the orange on this one. Yeah, well, we can at least check the transistor and make sure that that tests okay. So we're going to put the meter here on diode check. And since it's an NPN transistor, we can put the red lead over here. This is the base. This is the collector. So that's fine. And emitter, base to emitter is good. So this transistor should be fine. The MOSFET, unfortunately, I cannot check this way, but let's see what we get. Make sure it's at least not shorted or something. No, that's fine. Gate to drain. We get something there. Gate to source. Oh no, that's shorted. Well, the cool thing is that since we've got those other pads on the board, we can at least install like a 220 MOSFET there. So yeah, unfortunately this one's bad. And speaking of bad components, I did check all the capacitors that I removed. And these two big ones, one's a 22 microfarad, 25 volt. That one measured 1,938 microfarad, which is still within spec if they're 20% of like braided capacitors, which for the most part electrolytics usually are. So that's fine. The other one was a 3,300 microfarad. That one measured 2750, which is that one's still within spec. The two 470 microfarad ones, that's one of them measured 398, the other one measured 389, so even those are still within spec. The 247 microfarad ones, these little tiny ones though, those are a little bit below what they should be. So these here I'm for sure going to be replacing. The only problem is I don't have any on hand at the moment, but we're going to reinstall these and we'll test it out, make sure that the radio actually works. They should at least still do something, as long as we can get the radio to turn on. And then once we make sure that everything works, then I'll just go ahead and replace them later, because I do have some on order, but I don't have them yet. And one thing I didn't write down here was the ESR for all these capacitors. It was still good, like it was nothing high or anything like that. So these capacitors here, I'm still comfortable with leaving on the board, but not these. Wait a second, crisis averted. I just realized I had this in the wrong orientation when I tested it. So this side here is the gate. This here is the source. So that's fine. This side here is the drain. So that's fine there. That's not shorted. If we test from like here to here, then yeah, we have a short because those are all the drain. And from here to here, we should have like all these making contact together. So that's there. And that's they're all the same pin. So no, this should be fine. Yeah, my bad. Okay, so this is what we've got going on. I used some stranded wire that I twisted together, and I soldered it from one side of the board to the other. And I did the same right here as well, because that trace there looks like it's just ready to break, and I don't want it to like completely detach. So I took some braided wire and I split off like a few strands to go off in this direction, soldered it to that trace. And then I took a few other strands, soldered into that trace. And then on the opposite side, we can see how I took a little piece here and I soldered it to these traces going off to the connector for the speaker on power. And then over here we have it coming out and going off this way. I tried to tin the vias here, but they didn't want to take solder in. So unfortunately I was only able to solder it into like the top part there, but it's fine. I got continuity all the way across. There's that other via there that was damaged for that capacitor, so I just have all the strands coming off into this direction. When I stick the capacitor through, then I'll make sure everything gets tinned. Now, as far as this section here goes, I do want to make sure that we've got enough copper here, because this is like the main 12 volt trace coming from like battery going into the rest of the circuitry over on that side. So what I decided to do for that is I got a piece of this copper foil and I shaped it so that I'll be able to solder it into this area right here. It'll fit just like that. And I also removed that little tiny capacitor that was there. I did try to measure it, and it seems to measure about 100 nanofarads. So I'm going to have to find something similar. But that's like off to the side here, so I can put that on later. What I want to do now is I want to get this piece of copper soldered in. And then over here on this side, I do need to run a trace or a piece of wire from this side of the board over to the other side, because there is broken continuity between this trace going here off to the gate of this MOSFET and the opposite side of the board that controls it. So it's definitely probably not turning on due to the fact that this MOSFET here is not working. And so other than that, I just need to coat some of these areas with the solder mask material. And then after that, I can put the capacitors on and we should be good to try it out. So real quick here, I'm just going to show how I'm going to do this here with this copper foil. So first of all, I'm just going to dab a tiny bit of solder like over on this side. There, we really don't need much. I'm going to put a little bit right here. And I'm going to put a little bit over on this side. Now that that's covered there, or not covered, but that I've got some material there, I'm going to put some flux all across this thing here. And what I'm wanting to do is I'm going to heat that copper foil up from the top. And as I run the soldering iron across like in this direction, I should hopefully get that solder to like flow underneath and make that foil stick to the trace. So I'm going to try to bring it in and get it aligned as best as possible. And what I've done here, I don't know how you're going to be able to tell, but I've kind of give it a curve, so that way it wants to like touch on the ends there. So as I touch this to the trace, and it flipped over on the wrong side. Okay, that's probably as good as in alignment as I'm going to be able to get on that. So as I, come on. So as I move the soldering iron across, I want that solder to kind of like wick underneath it and make it stick. Okay, I think that's about as good as that's going to get. So I'm going to tack this side down now. Okay, I think that's going to be good for that. Did it shift? It did not shift. Okay, it looks pretty good. Okay, now I'm going to try to hold it from back here. And I'm going to try to run the soldering iron across the top. And at the same time, I'm coating the top side with solder so that it's not like bare exposed copper. I'm hitting that second blob of solder. I could feel it underneath, and it melted. And the last of it right here. Now, I'm not going to worry about this hole here because I can just puncture that. It's really thin foil, so it's not a big deal. Try to get the edges here to sit kind of flat. All right, so yeah, I'm definitely happy with how that turned out. And now I can just take this really sharp pick here and I can puncture that. There we go. There's our hole for our capacitor. Jeez, if I could say that. I think I'm going to tin this over here a little bit more though. So there's a close-up of that spot here. There's a few little areas here that don't want to tin, and so I'm trying to clean them off with this fiberglass pen. And I'll try again. All right, that's everything completed, and I've got the solder mask applied and protecting everything that I put on there. So I also jumped the trace that went to the gate on the MOSFET that's over here. So now it's just a matter of populating everything again, and then we can try it out. Turns out that these two capacitors here that I thought were for audio probably are not. It looks like they go over here to this area. So I think they're actually for the accessory and the lamp inputs. So even if they're not up to spec, it should still be fine. Even though I'm probably just gonna replace them anyways. Like I said, I got some on order. So yeah, I'll just populate everything, and then we'll be ready to try it out. All right, so got everything repopulated, and I've got this connector resoldered onto the board there. I've cleaned it up a bit. You see right there where I had that little bit of wire sticking up. I got the capacitor resoldered to that. The only thing I have not put it back on is that little capacitor that was right here. I still got to find one. But I mean, like I said, it should work even without it. I think that's just for maybe like a little bit of noise suppression. Oh, I also forgot. I need to put this little switch back on here. I only removed it because I wanted to clean it up before I put it back in. That little switch there is just to switch between like European and US stations, I guess. But I'm going to take a break for a bit here because I've been at this for a few hours now and I'm freaking starving. So we'll be right back. All right, we are back. So I got the switch back in there, and I originally thought that maybe I could just clean it up with some contact cleaner or something, but I tested it with my multimeter before I did anything, and it had extremely spotty contact. So I ended up just opening it up. I cleaned all the contacts with a little fiberglass pencil, make them all nice and shiny, and then after that I applied a little bit of dielectric grease, reassembled it, and the contact was so much better. It was to the point where, like, if you wiggled the plastic part, it would lose contact, and it was just really, really bad. So after I did all that, like, it was completely solid. So that's reinstalled. I don't have any power hooked up to this yet. I don't have the antenna soldered in place. I don't have the amplifier clamped to the heatsink yet. Like, it's not completely put together. It's just in here enough to test it out. So I'm going to start by setting the power supply to 12 volts, but I'm going to limit the current because I don't want to accidentally fry anything. All right, so I've got the power supply just limited to about 300 milliamps. I think that should be enough just to test this out. So that's going to be negative right there. We know that that's definitely ground. Now I'm going to hook this up here, and I'm going to keep an eye on the power supply, see what it does. And okay, it went down to about 9 milliamps, so that should probably be okay. We have nothing going on here, and we shouldn't be able to turn it on. We can't. So now, the question is the yellow or is the red one the accessory on this radio? I don't know, but either one of these should be a positive input. So let's see what happens when we hook up the red positive, and let's tilt this up here so we can see it. All right, let's see what happens here. It did not come on. Okay, let's try yellow then. It did not come on. Okay, I just realized that when I hook up the red to the positive here, the current usage does go up to 60 milliamps. So let's see what happens when you push this button. Ah, there it is. It does work. So that's the auxiliary input. That's for radio. Switch the band over here. All right, so that stuff seems to be working. Okay, so now because I don't really have an antenna that I can hook up in here to, try to tune in stations, what I am going to do is I'm going to hook up an audio input or source to the input. So these two right there. Then I'll be able to test and see if we got any audio coming out of the amplifier. Okay, so I got my phone here playing some copyright-free music, and then I've got this jumbled mess of cables here going to the input. So I'm going to hook up the accessory lead here to the power supply. And the power supply is turned off. I forgot to turn it back on. And now I was going to use these needles adapters to like latch onto these cables here, but I think it'll be faster if I just kind of do it like this and just probe them from the ends where they're cut, because there are some like wires, like exposed, and then we'll be able to hear if we get sounds out of the speaker. So let's turn the radio on. Oh, need to hook this back up. There we go. Okay, and let's hook it, or let's put it to auxiliary input. Let's turn the volume down. I don't know. Let's see. What should we go? I guess let's do 15 or 16, whatever was in there. Now let's see if we got audio coming out. And I hear nothing there. Nope. Getting nothing. Should have probably made sure that the speaker is actually good, because I think I had one that was bad. Now that's working. Yeah, I'm not getting audio output from any of the speaker outputs. And I actually just realized that the power supply dropped down to 7.44 volts because apparently 300 milliamps is not enough here once the amplifier is running. So let's see, at 500 milliamps. Okay, now we're back up to 12 volts. So that could be part of the reason why it wasn't working. I'm going to turn the volume back down to, let's say, 15 again. I guess it goes in increments of 2, so it goes 14 to 16. All right, let's see if that works now. Okay, this is a much more convenient position, so I'm going to turn the volume up. I can't see what it says, but it should be up now. And we got audio there. Got audio there. Kind of hard to try not to short anything out here. yeah, so all channels are working. Sweet. Well, I'm glad I caught the voltage thing before I did anything else, because I was about to start going down the rabbit hole of checking stuff that wasn't a problem. So that's good. Got the radio mostly reassembled now. And a few of the things that I've done is I put a piece of tape right here on this ribbon so that it doesn't come off. And that way it's kind of how it originally was. I did replace the capacitor down in there. It turns out that I did have some brand new ones in a little bag here. So that's a 100 nanofarad capacitor, or 0.1 microfarad. Funny little thing about the capacitor that was originally in there, it was like super tiny. So when I was trying to like test it to figure out what value it was, and I was having to like grab it with these tweezers at one point, I had it pull a Team Rocket on me and it went blasting off, and I thought that's the last I'm going to see of that capacitor. But I actually did find it. It turns out it landed right in there inside one of those holes on this breadboard. So the only reason I caught it is because this thing was like sitting out there, and I noticed an abnormally shiny thing like in one of the holes inside of the breadboard. So that's how I realized that it was in there. So yeah, just fun little thing. But that capacitor that I put in there, it's 1206 size, so it's bigger than the original, but it's the same value, so it's totally fine. One other thing here, the reason why, these capacitors had like adhesive on them and stuff is just to prevent them from like shaking loose or whatever, breaking off from vibrations. So I did want to reattach them somehow, but I didn't want to use any adhesives that, may further corrode the board or anything like that. So I did end up using hot glue, but a trick that I use whenever I'm going to use hot glue like this to attach things to a board so that they don't like rattle loose or whatever, is I'll preheat the board with like the hot air or whatever, so that it's the board is nice and warm, so that when I do apply the hot glue, it doesn't like immediately start solidifying. It has a chance to kind of like settle down and stick to the board, and it makes like a really strong bond. So I'm really happy with the way that turned out. I also put it around these other capacitors here, and I also got the little tabs right there from the chassis. Those are soldered onto the board. I reattached the antenna cable, that's soldered onto the board. So this is technically ready to go, but I do want to replace those two capacitors when I get those in. However, I do want to get this video finished up so that I can move on to other things. So as soon as those come in, I will swap them out, and that should be the end of this. I do want to give it one more test though. And since I have the antenna plugged in or attached, I'm going to try to tune into like a radio station, make sure that I do have like audio coming out of it. And assuming that that's all working, then that should be the end of this. So let's give it a quick shot here. I'm just going to set it up and see if we hear anything. Okay, since I don't have like an antenna here, I just stuck in this test lead into the antenna jack, and it's not in there very well, so it's just kind of sitting there. But I think that should be enough to try to pick up a station. So I'm going to drape this over here somewhere. I got this little mirror here, and I'm going to try to tune it to a station. I noticed that sometimes when like a station comes in, it pops up like a little symbol like up here or up here somewhere. It was. So as soon as I got a station tuned in, I'll probe it and see if we've got audio coming out. So let's see what I can find. Okay. So yeah, there's a little symbol up there. You might be able to see it. And so I'm going to turn up the volume. That should be enough. Let's see if we hear anything. Yay, we have audio. Kind of hard to poke these from the back. Yep, all channels are working. So pretty happy with that. And I think that's going to conclude things. As for the stuff here on the top cover, I'm just going to scrape the rest of that off and then just leave it as is, because I don't really see a reason why they would have added that to begin with. And it should be fine without it. So yeah, once I'm not going to put this on just yet because I'm still waiting for those capacitors. But yeah, once those come in and I swap everything out, then I'll just put everything back on. So yeah, that's going to do it for this one. I'm happy that it's working. And thank you all for watching once again. I'll see you guys around the bench.